Yes, Mike, you're
Perfect.
muted.
Thank you.
All right.
Perfect. All right, everybody. So we'll continue on. So I'll keep throwing in little videos there if you guys like that kind of stuff. It's all done through my cell phone. So, and I spent a lot of time at my plant. Thank you for the nice comments about the organization. I keep a very clean plant, and it's very important to have pride in what you do. So let's go into flocculation. We know already, the quick recap is we got rid of the big stuff through the screening. We talked a little bit about the colloids, the organics, the colors, the negative charges. We added that positive charge. We know we need alkalinity to make that work. And we created these flocks through the coagulation process. So now what we're going to do is take these flocks and we're going to mix them very slowly. And what we're trying to do is promote contact between all the particles in the water, because we want to make these things bigger, much bigger, and like the snow, that snowflake looking flock that you saw in the little video there. And that's flocculation. Let's let these things work for us, because the more they get bigger, the more easier it is to get rid of them. And that's what we want to do. Let's get these things out of there. As flocks collide, they become larger, right? And again, remember, these things are full, they're sticky, number one. Number two, they have charges, some negative, some positive, and they're going to stick together. The better we make these things stick together, the more they're going to be able to get out of solution, which is perfect. Flocculation allows the coagulation process, or follows the coagulation process, and is basically a period of mixing. So here's the thing though, we don't want to mix them too fast, because if we create these snowballs and these flocks, and if we mix them too fast, poof, they blow apart again. And then you're no further ahead. So it's very, very important to keep the mixing at a very slow and easy rate, or else bang, they're going to break all these things up again, and then you're in trouble. So always, you want the water moving, but not moving fast like you did in the rapid mix. By definition, the mixing ensures sufficient particle collisions, and that's super important. It goes through a bunch of processes, right? And then, like, from a chemistry standpoint, it goes through like mass attraction, friction fit, and that's a fancy way of all these particles are going to collide. The magnet part or the charge part will allow them to stick together. Charge neutralization as well. So we just kind of keep everything all together. In the flocculation process, it's essential that the flocculation agent be added slowly. Some plants, what they'll do is they'll add a flocculation agent, and we'll talk a little bit about that. You can actually, the words flocculation agent and polymer or a polymer aid are all very interchangeable, and they have a certain reason why we do it, but we'll talk about that in a bit. All we want to do is basically, coagulation is destabilizing those charges. Flocculation is now allowing contact between all these tiny flocks to make them bigger. That's really all we're doing. We're going to have to, sometimes there's stuff that happens. So think about if there's not enough weight, right? We got all these fluffy flocks and they're not settling very well. We're going to add extra things in there to make them sink, or liquid weight or liquid strength. And those are what we're going to be calling polymer. And we'll talk about that a little later in the lecture here. These newly formed flock particles are fragile, right? They can be broken apart by mixing too fast, or currents or something like that. So we got to be really careful that we don't break them. There's a bunch of different, and again, inline mechanical mixer, vertical flocculators, hydraulic, which is just using water. Some places they use different, like a route that the water goes through that it'll mix as it's going. Turbines. These are all different ways. As long as you're keeping the water moving. Because two things, you don't want the water to stop, and you don't want it to mix too fast. So really important to keep the water moving somehow. Typical, it's the way what you saw in the video of my plant, where you have those really large mixers. They're moving very slow and just enough to keep everything in suspension or moving around so they collide with each other. So that's super important. We'll talk about coagulant aid, and basically what they are a bigger flock agent, and it could be negative and positive. Think of it like liquid weight or liquid strength. A lot of the time they're chains. They're heavy chains with a bunch of bonding sites on there. And all those flocks, those balls of flock can actually attach. They can come as positive, negative, or a little bit of both. And if I'm having problems settling my flock, if that's the process I'm using, this will help it, give it some weight or give it some strength. So for my plant, as you saw there, when those flocks left the flocculation where you saw that light, I put it to a dissolved air flotation. And a dissolved air flotation has air that's pushing these flocks to the top. And you saw that in that brown goopy mess. Now, if those weren't very strong, the air could actually damage the flock. So I'm going to add a little bit of a coagulant aid to make my flock strong so that the air doesn't break it apart. So I actually use a coagulant aid or a flocculation agent, and that's what they're called. It will keep things strong or keep things heavier if I need it. They're also called a polymer, right? And again, polymers are employed to promote faster and better flocculation or removal of these flocks. They're high, and you can get them all different types of weight, actually, depending on the process that you need. For me, I don't want weight at my plant because I'm floating stuff, right? But I want strength. Some plants, subtle. They need to have weight. So those are the things you have to look at depending on your process. Under the microscope, this is what it looks like. And you can see here, my drawing, this is a typical polymer. It could be long or it could be short. It could be lots of weight built in. It might not be. But each of these sites here can take on a flock. So you can see the flocks are made up of positive and negative and all these little particles that were floating around. So that is the coagulant and the colloids mixed together. Think of this as a bus. All the people get on the bus gets heavier, it will sink. Or this is big enough so that the air can float it to the top. It all depends on your process. For me, I don't want heavy flock. I want something lighter and fluffier. So I would have a smaller one. I would only have maybe these, and so that when the air bubbles come up, they're pushing that to the top. And you saw that in that video I showed you. Some places they want to sink them, so they'll have heavy polymer to sink these things out. All right. Okay, so we're going to look at, I've made the flocks, I've got them ready to go. Now let's get rid of them. Let's totally get rid of them. And that's our next process here. There's ways to do this, and we'll talk about some of the main ones that are used to get rid of them. This could be called a number of different things. Some places they call this clarification. It also could be called sedimentation, dissolved air flotation. So there's a bunch of different terms that are used depending on the process that you have. And all we're doing is removal of these flocks. That's how you have to think about it. We created these things. Now we got to get rid of them, right? Because really, we don't want them in the water anymore. We made them appear. We packaged them up so now we can get rid of them. And this is what we're doing now. And there's a number of different ways that we can do that. It used to always be called sedimentation, and that's no longer used anymore because there's other processes, such as what you saw at my plant, dissolved air flotation, where we're actually floating that sludge, that product to the top. So I like to use clarification, which makes a little bit more sense because we're not always settling things out. Why are we doing this? We're removing those suspended solids. We're removing those flock particles. And we want to do that to reduce the load on our filters. Because if we sent all that stuff to a filter, it would plug that filter very quickly. So we don't want that. Sedimentation, again, it includes the solid contact clarifiers, sand ballasted flocculation, which is quite widely used now. Square or round sedimentation basins, we'll look at those. But the big thing is, let's get this stuff out of there. And that is the number one thing. Suspended solids, and it could be anything, turbidity, or these flocks that we created are denser than water. And we're going to try to remove these by gravity. That's the easiest way to do this. When we stop the flow or slow down the flow, things will fall out of solution. And that's really what we're doing here. We're allowing it to settle or stop moving long enough for it to fall down and collect at the bottom of these tanks. Again, our whole thing is to lower the solids concentration. And if I do that, my filters will run a long time. I'll get a long filter run. And we'll talk about filters probably, I think it's next week. Velocity is a pretty important concept, and it's the speed of the water. And that comes up in a test a number of times. Speed is super important here because if it's too fast, these things aren't going to settle. We need to have it below 1 meters per second. And that's to keep things, if it's above 1 meters per second, it will stay in suspension. So you have to slow everything down below 1 meters per second. And that now allows time for this stuff to settle to the bottom. The type of particles you have sure make a difference too. And of course, denser particles will settle out first. So if you have a lot of sand or silt in your system, that sand's heavy, right? And so that's going to settle out very quickly. So if you put something that's light and fluffy, it takes a long time to get to the bottom of your tank. You've put a couple of grains of sand in there, it's going to fall very, very quickly. So you have to design these basins, whether they're square or round, to reach long enough to allow what you have to settle out. And sometimes some places put in sand in there. They'll inject sand, coagulant coated sand in, because it will attach the particles and drop it very quickly. In time, most of the suspended matter would settle. We know that, but we don't have much time. We don't have hours and hours and hours to wait for water to our particles to fall out of water. So we have to try to go along, and that's why we do this. Polymers are our friend when it comes to this because we want these things to settle quicker. Let's talk about the typical rectangular basin first. And this basically, what's my little pen here? We'll make it red. So basically your water's going to come in, it's going to be moving pretty fast, and all of a sudden it's going to be in this big open tank, and it's going to settle. It's going to, boom, it hits this big tank, everything's going to settle. This is the inlet zone. This is now, the flow is starting to slow down. The bigger particles are going to start settling to the bottom first, and as the water's moving slowly through this basin, more and more particles are going to fall to the bottom. And that's what you want. Hopefully, by the time you get to this outlet zone, right, most of the water's clear and most of the product's at the bottom here in the sludge zone. It's important that the clean water leaves here and it's free of any sort of nastiness, and that this sludge zone here, that you're removing this sludge, right, whether they have a rake or something, device down there to remove that sludge, because over time that's going to cause gases and smells and tastes over time, and you need to get that out of there. So there should always be something at the bottom of these tanks to remove this sludge and get it out of there. Proper maintenance is also very important to make sure that anything that's collected at the bottom is removed. You saw in that video I showed you where you saw my empty mixing tanks. I do that because I have to clean those out once in a while to make sure that everything is clean. It's just part of regular maintenance. And that's the rectangular. They use a thing called plug flow, and all the liquid advances together, right? You've got to be, that flow is moving as a unit all the way through that basin. The inlet zone, we saw that there. It's basically smooth transition from the flock basin. It slows that flow right down. It distributes that water evenly across the whole basin. And it should reduce those short circuiting. It slows that velocity down, and the big stuff starts to fall out in this inlet. The settling zone, again, that's usually the largest portion, and that's where most of that settling happens. And again, typical detention time should be about 3 hours. It takes a long time to get through there. At the sludge zone, like I said, we have to do something there. Temporary storage, of course, but we got to get those out of there. They can't stay there. You got to get them out. And then the outlet zone, and that's the transition from the sedimentation process or the clarification process into onto the next process, which is going to be filtration. Let's talk now about the circular tanks. Circular tanks are pretty popular. Flow comes in through the center of that circle, okay? And it works outwards, right? So it has to flow basically in a circle and come out through the top. It's like a cone at the bottom, and then there's a scraper. And I got a picture, good picture here of this. So basically, inlet water comes in. It's gonna move in here. This is your settling zone. It's going to leave. And as it's moving through, these rakes here are moving. Sludge is going to go into this receptacle here, and the sludge leaves, and the good water moves to the next process. And this is really typical in a lot of water treatment facilities have round, and wastewater facilities also have round clarifiers, they call them. And that's pretty typical of what you'll see out there. The older stuff is really square basin, but it works well. But you'll see a lot more of this circular tank. Another thing you'll see too, and my plant used to have this particular unit, was something called an incline plate settler, also called a lamella clarifier. And basically what we do here is move water up a 60 incline plate. You can see here, this is really cool. Up these plates in red there, the dirt and stuff is going to slide down. It can't hold on to that. It's going to start sliding down. And you can see as dirt and flock is sliding down, it's going to carry, the water going up has to move past it. So it actually almost filters it almost a little bit. As the water's going up, it has to pass through the product and the flocks coming down. So it actually acts as a little bit of a filter, and it works really well. And this is called a tube settler or a lamella clarifier. It's important that this is going to be at 60 degrees or better. And it has to, 60 degrees. And that's the angle that this has to be in order to work. If it's any less than that, things don't work as well. So you have to always make sure of that. You can see a typical unit here, and I actually have one of these units at my plant for my backwash waste, and we'll talk a little bit about that when we get to that chapter. But you can see here, water's going to come in through here, and it has to travel up that 60% out to the end, and the sludge is going to move down and fall into this hopper at the bottom here. And that's really what it is. And it works fantastically. Again, I like to say the 60 degrees is the target. It works well. And there's no moving parts inside there. The water's doing all the job. And that's exactly what you want. There's no big mixers or anything crazy in there. It works fantastically. So I'm always pretty happy about that. And those are called incline tube settlers, lamella clarifiers. Sometimes I'll add a little bit of a polymer just before I add it to here. And that allows me to make sure that it's heavy enough that it's going to slide down that particular one. We'll talk about the solids contact unit. And a solids contact unit clarifier, it's a pretty hard clarifier to use. And it basically takes everything we just talked about today: coagulation, flocculation, and sedimentation, and it does it all in one step. Instead of having all these different processes, this is all done in one tank. And it's a lot more difficult to control because there's 3 processes that are happening inside here. And it's always really, really tough. Let's walk through this here. All right, I'll make it in green so we can see it. So what happens here is that our water's gonna come in and it has no coagulant in it yet. I usually add just before. So coagulant's added here. It's going to come in here. And what's going to happen here is there's usually a rapid mix that happens just before here. And that water is going to travel into the clarifier. So in it goes, it's coagulated. And when it's in here, this becomes the flocculation chamber. And there's usually a mixer in here, and everything's going to mix. Now, when it's mixing, a sludge blanket forms. So see this gray part here. This is a sludge blanket, and basically it's a bunch of sludge that's raining down. You can see those 60-degree things are also built in here. So sludge is sitting in here and it's floating. Also in here is bacteria, coagulant, flocculant, all the stuff is sitting in there. I'll answer that question in a second about the add more coagulant, but hang tight with that one. So basically what water's going to have to do is basically come in, get mixed, and it's got to work its way through this jelly layer. And in this jelly layer here, this dark layer, it has the coagulant, the flocculant, all these things are inside this jelly layer. And it acts like a filter. And it's floating in the water. And the water has to work its way through that and then through those lamella clarifier, those 60% things at the top. So it takes all these things that we talked about. So your coagulation, flocculation here, through a kind of a mini filter into a lamella clarifier, and out it goes. Very difficult to use because a couple of things can happen here. If I have too much sludge, it gets too heavy, which means this floating jelly layer right here is going to sink to the bottom and we're going to lose it. And we don't want that. In this case here, we want to keep enough here to stay in suspension. If it's too light, it will actually go up through the 60% and out it goes into our filter. And that's bad. So the game is here is to keep this heavy enough that it stays in suspension, but make sure that we're always wasting a little bit of it so it's doesn't get too heavy. So you have to really keep your eye on this to make sure that it stays in suspension at all times. Now, there was a question, is it possible to add more coagulant after the clarifiers? Some places do, and they call that a filter aid. And sometimes they'll add a little bit of coagulant after all this process here, and any of the processes, in order to help the filters. When we talk about filtrations, a clean filter does not work well. And we're going to talk about that next week. But the cleaner your filter is, the poorer it's going to perform. So we have to make sure sometimes to give it a little bit of dirt or a little bit of seed, that they call it, in order to make it work better. And sometimes, yes, they do add coagulant a little bit, and they'll call it a filter aid instead of a coagulant after the clarifiers. It could be the same product as what you used before, but definitely it is used. So hopefully that answered your question on that one. Okay, so that's a solids contact unit that we just talked about here. And what, by definition, it uses a zone of concentrated solids. That's that jelly layer as a filter to help in particle settling. And it's your job as an operator to make sure this zone of concentrated solids is good. Dissolved air flotation. And what I'll do, I will show you the rest of that video from my plant of my dissolved air flotation. And that's what you saw earlier. It basically, pressurized water is injected into the flotation unit under atmospheric conditions. It forms gas bubbles. And you can see in this picture here, what I do, my pen, right? I take some water, I mix it with air, and think about a soda pop, right? Imagine I shook that thing up and I let it go and I open it up. It fizzes up. There's a lot of energy there. And that's exactly what I'm doing here. I'm pumping air into a saturator and making it super saturated with air. And then basically when that air enters this tank, it's a lot of energy. And that air bubbles will push your flock, all that stuff to the top right here. And you saw that in my video there. All that stuff at the top, that's all the flock that I created. And then over time, I'm going to take a rake and I'm going to push that stuff out of there and get it out of the solution. The good water is going to leave at the bottom through those white pipes you saw, and the stuff at the top, that's going to go on to another process or get dewatered. But this is a very effective process, especially if you get the bubbles right. And again, if your flocks are too big, it won't work. We don't want ever for this stuff to settle. We want it to float. So it's really important to keep that floating. Okay. Sludge removal, we're going to talk a little bit more about sludge removal in a couple of chapters from now. And again, we don't want sludge to stay in there because what it does, it becomes septic and creates more taste and odors, right? And that is not what you want. It also takes the basin capacity away, right? The less capacity we have, the worse it is. All right. That's our last slide for today. I'm going to throw a couple of more videos on. I'm going to show you two more things before we go today. First one is, let's take a look at the DAF because so you saw the first part of it. I'm going to show you the second part where I'm actually scraping the flock away after it's been treated. It's pretty gross. The second one is, I'm going to show you how I add coagulant and polymer to my flocculation and my coagulation. So give me a second. I'm going to flip over to a video here. Okay, you should be able to see my my video here. You should see some rainbow-looking pipes. If you can see that, give me a thumbs up, please. Awesome. Okay, so what you're going to see here is the DAF unit, and I'm hoping this is the right video. I have two of them here, so if not, I'll throw the other one on. But you're going to see the product coming off the DAF, or the DAF itself.
No water leaving the DAF. It looks pretty clear. You can see it here. And that water there is coming from those white pipes at the bottom of the DAF that we saw earlier. Let's take a look at the turbidity coming off of that today. There it is right here. 0.25 turbidity leaving the DAF. That's pretty good.
Okay, so that's a good one. Let me just, I'm going to put another video on here. I took those with my cell phone, so I apologize for the quality of them, but they do the job pretty good. Okay, let's get this one going here.
Okay, so our skimmers are running. You can see how they're moving here. They're going to be moving that product over this way. The whole idea is to get rid of that stuff. The water underneath should be really clear, and you can see this going right now. Let's see if I can get a closer look down in here. Now those brushes are pushing that product towards what they call the beach. And the beach is that silver part that you see right here. It's going to push that, all that sludge and stuff up the beach and into that trough to the left here. Here we go. Imagine all that was in our drinking water before here. Here it goes. It's going to push it up the beach. And into the trough.
You can see that stuff's not very appetizing, and it is. It's a lot of that. See how it's kind of milky in color? So basically, those little flocks are all your color and organics, and there's bacteria in there, of course. But those are what we're trying to develop, right? This case, we see it because it's floating, but in a sedimentation basin, all that stuff would be heavy at the bottom, and it's this light, fluffy. It looks like oatmeal or some sort of paste. That's exactly what we're trying to form here. Those are those tiny little flocks that we created in the coagulation process. So it's pretty disgusting, really. All right, let's. I'm just going to show you now our coagulant room real quickly here. This is our main coagulant. It's room. We got a fairly large tank in this particular room, which I'll describe when we get there.
Next room we're going to see is the coagulant room. This is the plant's made coagulant. And we talked earlier about what coagulant does. It's our liquid positive charge. We also have a nice big large tank here. It's a little over 30,000 liters. Product gets trucked in. You see the pink hoses. It goes to the top, drops inside. And what we're going to do is we're going to pump this stuff. Now, tanks like this need to be accessed from time to time, and you can see here access points at this point. Product's going to leave through this network here and into two diaphragm style pumps. After the pump, it goes through some vibration dampeners.
So that gives you an idea. Typical, this is older style installation. It will have the diaphragm pumps. These are fairly large for the coagulant, and that's our main coagulant. Some of the new installations, and I'll show you our polymer because we also put a polymer on there. Newer installations use a peristaltic. So I'll show you that one as well. It's good to see. The peristaltic pump works really well.
Next room we're going to see is the coagulant aid room. And what does coagulant aid actually do? So this, if our regular coagulant isn't doing enough, what this can do is give us a little bit more charge when we need it. So if we have to get more color removal, this is what we're going to do. Again, we're using peristaltic pump like we saw earlier. It's turning really slow. You can see the rollers in there. We're making sure in our flow meter up here that things are running.
It's pretty typical for any sort. Use a peristaltic pump. It's a hose type pump, and we'll talk about that a little bit in future lectures, but it gives you. So those are some videos, and I'll keep putting some videos out there so you guys can have a good idea of what I have to deal with in my plant, and that I can apply some of this to you guys. So that is the end of today's lecture for the intakes and coagulation and sedimentation or clarification. We will continue our lecture next week, and we'll be getting into the filtration part of the lecture. So exciting that we're moving through that, and then into some of the specialized treatment stuff in further lectures past that. So thank you for staying awake with me today. And hopefully you guys learned a little bit today.
Thank you very much, Mike. You have a wonderful day today. I know it's a hard start of your day to be up at 4 with us, but we really appreciate it. And there are some of the guys who are not able to join us at the start, but of course we have the benefit of being able to record the activity, and so they will find the link, because I normally would send the link later in the morning, and they do follow. So Susan has asked me to inform them, the students there, that the exam is scheduled for the 19th of March. So I guess we're going to have to work towards that to prepare. Okay. So have a wonderful day, everyone. And see you later this afternoon at 3 for water distribution. And we have adjusted our regular webinar to begin at 5. So those of you who want to participate can just follow up and join us at 5 p.m. for the CAWASA Wednesday webinars. It's going to be, we have the Chlorine Institute with us this afternoon. The Chlorine Institute of the US, they're going to be doing some tutorials. Well, not tutorials, they're going to make a presentation on chlorine safety in water and wastewater. So see you at 3 for water distribution and at 5 for Wednesday webinar. Have a wonderful day, everyone. Keep safe.
Bye, everybody.
Bye.